Hi, this is Thomas. Welcome back. We're continuing with the topic of trigonometric identities. This is example number 4. Our requirements are, given that sine of A is negative 3 over 5 and 180 degrees is less than A is less than 270 degrees, and that cosine B is negative 12 over 13 and B is obtuse, find the value of 1. Cosine A minus B and 2. Tangent A plus B. So let's begin with cosine A minus B. And our first step in the algorithm is 1. Identify scenario, equation, or identity. Now we're actually going to be working with an equation, but first let's show what identity that we're going to use to analyze cosine of A minus B. This is compound angle identity with cosine and subtraction. Cosine A minus B is an identity with cosine A times cosine B plus sine A sine B. In order to solve for cosine of A minus B, we need to know cosine and sine of angle A, cosine and sine of angle B. Notice that we're given sine of A is negative 3 over 5. So we're going to work with another identity and use the sine A value we're given to find the cosine A value. The other identity is cosine of A squared is an identity with 1 minus sine of A squared. And now we're going to set up our equation. For step 1, identify scenario, we're now dealing with an equation. Cosine A squared equals 1 minus sine A squared. And we know sine of A is negative 3 over 5. And we'll square that amount. So cosine A squared, 1 minus negative 3 over 5 squared is 1 minus 9 over 25, which will give us 16 over 25. And now, in order to get cosine of A, we'll take the square root of both sides. On the left, we have cosine of A equals, and on the right we have plus or minus, the square root of 16 is 4, and the square root of 25 is 5. Cosine of A is plus or minus 4 over 5. Now, with two options, we want to use our scenario to decide which of these two values is relevant. So let's look at the coordinate plane and think about the scenario that we're given and evaluate the two answers we've come up with for cosine of A. So I've added a coordinate plane to the screen in the upper right hand corner. Let's think about our scenario. Angle A is between 180 degrees and 270 degrees. That means that angle A is in quadrant 3. And in quadrant 3, we are to the left of the origin, which means that the x value, or the cosine value, is negative. So of our two options for cosine of A, we want the negative value, negative 4 over 5. So now, along with the given sine value of A, we have the cosine value of A. Let's move to angle B. So as with angle A, let's use a Pythagorean identity to find the value of sine of B. Sine of B squared is an identity with 1 minus cosine of B squared. And in this case, we can set up the equation sine of B squared equals 1 minus the cosine of B we're given as negative 12 over 13, negative 12 over 13 squared, which equals 25 over 169 for sine of B squared. Let's take the square root of both sides. We have sine of B is plus or minus, the square root of 25 is 5, over the square root of 169, which is 13. Again, we have two values. Let's review our scenario to identify which sine value we want to use for angle B. We're told in the scenario that B is obtuse. What that means is that the angle B is greater than 90 degrees, less than 180 degrees. So if we go to our coordinate plane and move from quadrant 1, we end up in the quadrant that would produce an obtuse angle. This angle is in quadrant 2. In quadrant 2, we're now evaluating the sine value, which is the y coordinate. The y coordinate is above the origin, so angle B being in quadrant 2 means that angle B has a sine value which is positive. So sine of B is now plus, given our scenario, 5/13. And now we have cosine and sine values for angles A and B, so we can go back to our compound angle identity for cosine with subtraction. We'll set an equation now because we have specific values that we're using. Cosine of A minus B equals cosine of A, which is negative 4/5, times cosine of B, which is negative 12/13, plus sine of A, which is negative 3/5, times sine of B, which is positive 5/13, equals negative 4 times negative 12 is 48, over 5 times 13 is 65, plus negative 3 times positive 5 is minus 15, over 5 times 13 is 65. Finally, simplifying to 33/65. This is the exact value of cosine A minus B. So let's summarize by connecting this process to our algorithm step by step. So I'm going to go back and erase the labeling of step 1 on the left side of the screen. Step 1, identify scenario, equation, or identity. So our process is to find an equation cosine A minus B equals something given the particulars of our scenario. Step 2, identify relevant trigonometric identity. That's going to be the compound angle identity with cosine and subtraction. So step 2, I've identified my identity. I realize to use that identity I need 4 values. I only have 2 of those values. So another step 1 is equations that we are using to find the missing sine value for angle A and cosine value for angle B. And another step 2, identifying the relevant trigonometric identities for those processes. Here labeling step 2 2 more times. We're using the Pythagorean identity, cosine squared angle plus sine squared angle equals 1, with 2 different manipulations to get the outcome that we're looking for. 3, substitute. The first substitution was in the first Pythagorean identity. Later, we had another substitution in the second Pythagorean identity. And finally, in the final calculation of cosine A minus B, we had 4 substitutions inputting cosine A, cosine B, sine A, and sine B. And simplify to solution or desired expression, we simplified twice with our Pythagorean identities. Ultimately, for our final answer, we simplified to 33/65. We've completed requirement 1. Let's move on to requirement 2, which is tangent of A plus B. Step 1, identify scenario, equation, or identity. In this case, we are going to set up an equation. We need to identify in step 2 which relevant trigonometric identity we'll use for the equation. That's going to be compound angle identity with tangent and addition. Tangent A plus B equals fraction in the numerator, tangent A plus tangent B over 1 minus tangent A times tangent B. To move to step 3, substitute, we need to calculate the tangent values for our angles. Tangent A will be sine A over cosine A. Sine A is negative 3/5. over cosine A, which is negative 4 over 5, which gives us 3 over 4. And tangent B is sine B over cosine B, which will be 5 over 13 over negative 12 over 13, which equals negative 5 over 12. And now with the tangent values, we can go to step 3, substitute. So tangent A plus B equals tangent A plus tangent B, which will be 3 over 4 plus negative 5 over 12, over 1 minus tangent A times tangent B, 1 minus 3 over 4 times negative 5 over 12. And in step 4, simplify. 3/4 minus 5 over 12 simplifies to 1 over 3. And 1 minus 3 over 4 times negative 5 over 12 simplifies to 63 over 48, which is 1 over 3 times 48 over 63. Finally, 16 over 63, which is the exact value of tangent of A plus B. So, in summary, cosine A minus B equals 33 over 65, and tangent A plus B equals 16 over 63. We've completed requirements 1 and 2, and this concludes trigonometric identities, example number 3.